Hi everyone, my name is Hailee and welcome to the CSM video walkthrough for list mutation, what would Python do? So before we get started, let's go over some important concepts first. So one thing that you should know is that there are different ways to mutate a list and different ways to create a new list. So mutating a list is changing up our current list, and that can be done with our mutation functions such as list.remove, list.pop, list.extend, and so on. We also have this notation right here, which is a plus equals 1, which is different from this one, which we'll get into, but this one will completely mutate our list. It will just change our list so that this 1 is added to the end. We also have ways to create a new list. So one way is to slice a list. So a sliced from 1 to 3 will create a new list, and as well as a is equal to a plus 1, which again is different from this one, as this is list equals list plus another list, and that will create a new list A. So that's one really important concept that you should always keep in mind. So let's look at our first problem. It says A is equal to the list 1, 2. So we do A in the environment diagram and make it point to a list with 2 elements, with the first being 1 and the second being 2. All right, now we have a dot append, and whenever we have append, always think of it as adding one box to the end of our list. So even if we have a list with multiple elements inside of it, if we're appending that, we always just want to create one new box at the end of our list, then use a pointer to point to the list that we have appended. Now, when we output A, that's going to return 1, 2, and then a nested list 3, 4. Okay, now we have B is equal to list A. This is also going to create a new list, and what it's going to do is it's going to look at A and just copy down its contents. So 1, 2, and here we have this idea of shallow copying. So we learned this in week 6 CSM, and that's when we have a list. Like in this case, we have 3, 4, a nested list, and list A, the third element of list A points to 3, 4. When we copy list A in this format, it's going to be shallow copied. So this nested list is going to be pointed to from by B. And you might be tempted to maybe create another 3, 4 list and point and have a pointer to that. But in this case, that's not going to happen. So now we have A of index 0 is equal to 5. So index 0 is the first element of A, and we are going to change that to a 5. We have index 2 of index 0, index 0 of index 2. So let's go to 0, 1, 2. That is index 2 right here. And then we index 0 from that, which is going to be this 3. So this is going to change to a 6. And notice how when we changed this nested list from A, it also changed the nested list from B. So this B is also changed due to our mutation of A. And so it's going to output 1, 2, 6, 4. Okay, now we have a dot extend. Extend is different from append in that extend always takes in an iterable. So lists, and in this case, we only have a list with one element, but in the case where we had a list with multiple elements, let's say 7, 8, 9, then this extend function is going to create 3 new boxes at the end, unlike append, which will only create 1 new box and have a pointer. So without what a.extend 7 looks like is it's going to create 1 new box at the end of 7 and add 7 to the end, the list 7. Now we have a plus equals the list 8. And remember earlier I showed that that is going to mutate our list. So again, we have an 8 at the end of list A. All right, now we have A plus equals 9. So you can see here that this A is a list, but this 9 is an integer. So when you try to concatenate two different types, such as a list and an integer, Python is not going to allow you to do that, so it's going to output an error.
Sorry, the video got cut off, but now when we see what A is outputting, this is what we will get because this entire thing is A. So we start off with the element 5, 2, then the third element is the nested list 6, 4. Then we have 7 and 8. So that is the output of A. Now let's look at the challenge problems. The first one says B index 2, index 1. So B index 2, which is this list, and index 1 is 0, 1 is this element with a 4. So we want to change that to whatever is outputted by when we slice list A from index 2 to the end of the list. So 0, 1, 2. So we start here and we slice until the end, and this is what we want to set this element equal to. So let's do that. First, let's set this element into a pointer that has 3 elements, so 1, 2. And that is, again, because this A list sliced from 2 to the end has 3 elements. So this also has 3 elements. And the first element is a pointer to this list. So if we want to do the same thing for this, we want to set this first element a pointer to this list. And the second and third elements are 7 and 8. Now our last line of code says A indexed into 2. So A, again, indexed into 2 is 0, 1, 2 is this list right here. Then you want to index into the element 1, so 0, 1, which is this one, which is a pointer to this list. Then indexed into 0, which is the first element of this list, which is this one, and it's a pointer to this list. And finally, indexed into 0, which would output 6, since that is the first element of this list right here.